Hi guys, my name is Manish Kumar, and in today's video what we're gonna do, we will just have a quick recap on all our previous machine learning videos, and then we will talk about neural networking, and then we will go into the back propagation. So let's start with quick recap. So what is machine learning? Machine learning is basically we begin with data and we have a model and then we train the model. So in our previous video, in part 1 and part 2 video, we talked about a linear data pattern where we have a data set and we try to find a best fit line which we can start using for prediction. So we had a pretty good understanding around it. Then we talked about weights and biases. So we have input and then input multiplied by weight, and then we add a bias which allow models to shift. Like in this example, W1 into X1 plus B1. This value we use as an input for the activation function, which is F W1 into X1 plus B1, and it gives us the output. So one important thing here, I just want to remind you that when we say like we need to train the model, basically what we do, we actually work to figure out the weight and bias values. That's our goal. And to do that, we have a set of input and a observed output, and we give input and compare the output with our observed data. And we try to reduce the difference of observed and predicted data because that we call the error. And we change the value of weight and biases with a certain rate, and that rate we call as learning rate. So learning rate controls how much we adjust weights after each error. So if it will be too high, it will be overshooting. If it is too low, then we will feel that it's a slow convergence. So basically, we reduce our learning cost by putting the right learning rate. To optimize it further with the given learning rate, we use different algo like gradient descent we talked about. So then we talked about chain rule. So basically chain rule helps you figure out how the first function change when the original input change. So if in this example, if we have z equal to fy and y is equal to gx, then dz by dx is equal to dz by dy into dy by dx. And we talked with an example about chain rule in our previous video. Then next is the activation function, where we talked about different common activation function. We talked about ReLU, we talked about sigmoid, tanh, and then we have to discussed some activation function which we choose based upon a requirement. If we are trying to find out some kind of probability between different like animals, like if is it a cat picture, dog picture, horse picture, what is this animal is, all those kind of things. So we talked about that. We created or developed a neural net where we use different activation functions, and we try to train our model for our x raised to power 3 pattern, and we see how the data is, like how much loss using different functions and what are the different parameters we should consider when we are choosing the right activation function. So let's talk about a little more the neural network. So what is neural network? Basically, neural network has three key layers. One is the input layer, and the last is the output layer. Between input and output layer, what we do, we pick the input layer, we perform a linear operation where we multiply by a weight and add a bias, and then we use this value and run a activation function at the top of it. And the output comes after activation function is called first hidden layer, the hidden layer. And then we further use this hidden layer as an input for next linear and activation function combination. And if you remember the code we wrote, there was like we have six iteration where we went through linear and activation function, linear and ReLU to get the right results. So basically input and output, these are like one layer both side, and then there can be multiple hidden layers. In real world, it's like hundreds, thousands, depending upon the complexity of data. Then in the neural networks, the each node where we have the output of this activation function is called the neuron. So neuron is basically the process's input to produce output using an activation function. So here is a diagram what I draw for you to have an understanding about neural network. So in this diagram, it's a lot of written here, but let me try to explain this. It is not as complex as it looks like. So we have here the first layer, which is x1, x2, x3. This is the input layer. Then the second layer, h1, h2, h3, h4, that is our hidden layer, the first hidden layer. And if you will see, all input x1, x2, x3 are connected to each of these uh, hidden layer node. H1, H2, H3, H4. X1 is connected to all these four, X2 is also connected, and X3. And at each connection, there is a weight, W1, W2, W3, and so on. So what is happening here, that X1 is connected to H1 with weight W1. And then under each node, there is a bias value, which is B1. So the value coming for H1 is W1x1 plus W2x2 plus W3x3 plus B1 bias. And then if you will see at the top here, I write a function we are using in this is like a ReLU. Then we are passing this value into a ReLU function, and the outcome is called H1. Same way we have for H2, H3, H4. Now we have the first hidden layer. If you will see further and go to the second hidden layer, all the nodes in first hidden layer are again connected to all four nodes of the second hidden layer. So H1, H2, H3, H4 are kind of now working as an input for second hidden layer. Same thing again, each connection has its weight, its own weight, and then we multiply and add them, W1 into H1 plus W12 into H2 plus W13 into H3 plus W14 into H4, and there is a bias B5 plus B5, and we pass this value to ReLU function and we get the value H5. Same way H6 we get H7 and H8. Now H5, H6, H7, H8, which is our second hidden layer, works as a input for our third hidden layer, and we get value H9, H10, H11 and H12. Then at the last we have our output layer where we have two nodes H13 and H14, and in this example I use the softmax function. Same way we multiply the node input value with the weight, and once we multiply, we add all those four values, and then we add the bias value B13 and pass it to softmax function, and we get the H13. So this is kind of how the neural network works. Now to train this neural network, basically we need to work to find the right value for these weights and biases. So we have million of inputs and corresponding outputs, expected outputs. We start with some random values W1, W2, 3, all the weights and biases, and we calculate what is our output. And from there, we start that what is the difference between our observed data and the output. And that we call error, and then we calculate the gradient, and on that gradient we multiply by the learning rate and find our step size. And using that step size for each weight, we tune the values or change the values of the weights and again perform the same operation. So this method where we have an output, on the output we find the loss, we measure the loss or error, and using that error and the learning rate, we find the next step size and tune all the weight and biases value using based upon the step size coming for those weights, and then we again perform the same operation. This entire algorithm is called, or the logic is called, the back propagation. So in the back propagation, what are we doing? First, we do the forward pass where we have input and some random values and we find what is our output. The second, we compute the loss and error, which is like the difference from what was expected and what is the predicted value. And then third, we start the backward pass by calculating the gradients and using the chain rule. So we update weight using gradient descent, and then we again calculate, go forward pass, and then again same thing until we reach the expected point. So how is it working? If you will see, I just like shrink down the neural network to the bottom of this page. At the top, I try to write that sum of error is basically what we are doing is that we are find the difference between the observed data and the predicted data. And then we for each weight, what will be the step size for weight n, we find the weight n minus the derivative of sum of error square with respect to the weight n, and then we multiply it with the given learning rate and use this for each weight. We find the derivative with respect to weight 1, weight 2, weight 3, and so on. Similarly for bias 1, bias 2, bias 3, and so on. And for each we find their step size and again tune the values and again work on that, and we keep iterating it until we get the expected results. So that's how the back propagation works. So thank you so much guys, and please don't forget to subscribe my channel, and thank you so much for joining the session.